Hello everybody and welcome back to our review videos for our AP Environmental Science exam. This unit is going to be Unit 4, it's Earth Systems and Resources. But before we get into the nuts and bolts of the unit, I wanted to remind you guys, the College Board videos that are on the YouTube channel for them, they're amazing. If you get a chance, start watching those. They're finally caught up to the point where it's new material that's going to be tested on the AP exam this year. So they're doing a good job breaking it down, and in the description of the video, mentioning which parts of the AP material it's covering, like Unit 1.4. It's the section, Unit 1, Section 4 of that. It goes into explaining it. I strongly encourage you guys to watch all those prior to the AP exam. Knowing how to answer the AP exam questions like we've been practicing in class, that's only one part of it. You still need to know the material and the content well enough in order to be able to answer those. They're going to look for making interconnected answers between all the different units this year. So you're going to have to know all units and how they relate to one another. The College Board videos are doing a really good job prepping you for that by spiraling and relating back to past material, all those things. I do encourage you guys to do that. If you're not going to watch those, go back through and look at our PowerPoint presentations. They're all found on Moodle. If you don't have the ability to get on YouTube and spend the time watching those videos, go back through, read the chapters in the book. They're all posted on Moodle. They're all the PowerPoints are posted on Moodle. If you need the enrollment key, it's sustainability. So make sure you're putting that enrollment key in, getting into Moodle, practicing, studying. You need to know units 1 through 7 inside and out. All right, so picking up with the new material. Well, review of the old material in a new form. So when we look at this, the first thing I want you guys to think back to are plate tectonics. And we have 3 types: convergent, divergent, and transform. So go ahead, take a second, pause the video here, and see if you can remember what's happening at these plate boundaries. Hopefully, after you paused it, you were able to figure out that convergent is when the 2 plates are coming together with one another. They're not going parallel, they're perpendicular to one another, slamming in. Think about it like a head-on collision between cars. Cars going the opposite way on a one-way street, it's going to have a head-on collision with another car. That's a convergent boundary. With divergent boundaries, they're moving away from one another. And with transform, now they're going parallel but opposite directions. So they're sliding past one another, or trying to slide past one another. The key to all this is they're trying to do this, but there's an extremely large amount of friction because you're dealing with huge plates of rock. And if you guys remember to when we talked about the tectonic plates in school this year, we said the crust of the Earth, it's sort of like that crust on a Klondike bar. When you bite into it, it cracks and creates, different chunks of the plate that are there. So that crust is a solid rock that we have on our planet. That's that lithosphere. The lithosphere, again, is the crust. That's that solid part of our planet. But right underneath that lithosphere is that semi-solid asthenosphere that kind of jiggles like jello and moves around slightly. It's sort of like a silly putty layer. So that solid rock crust is kind of jiggling and moving. So what we end up with are cracks and fissures across that lithospheric plate. And those cracks and fissures are these tectonic plates that we have. Those tectonic plates are trying to move constantly, but since they're made out of rock and the edges are jagged, they're trying to move, but it's really hard for them to move. So there's pressure building up, and then all at once that pressure can be released. And that's when we have these geologic processes happening, earthquakes and volcanoes and different things like that. So we're going to go into these different plate boundaries and cover them in a way that they might show up on the AP exam. So looking at our first one, the divergent boundary. Again, this is where our plates are moving away from one another. We can see this one's moving towards the bottom right of the screen. This one's moving towards the top left of the screen. They're pulling apart. And my wonderful wife actually bought something for me the other day to show this to you. And I had it under my leg just to warm it up. Laffy Taffy, it's my favorite candy. So this does a great job showing divergent boundaries. Hopefully it works. I'm not positive it will, but hopefully it works. So this would be like our plate boundary. We have, plate 1 over here, plate 2 over here. They're going to try to pull apart from one another. And as they're pulling apart and being exposed to that pressure, you can see that the Laffy Taffy is getting thinner and thinner and thinner. So you can see over here, the Laffy Taffy is much thinner than here and here, where the 2 plates are at. And it's getting thinner and thinner and thinner and pulling apart. And that's the main thing that's happening at this divergent boundary. So what we have, oh, my hands are sticky now. So what we have here, you can see the plate's getting thinner. The oldest part of the plate is over here. Well, no, the oldest part of the boundary, I would say, is over here. The newest part is here. Because as that's pulling apart, that plate is getting thinner and stretching, because it's not just, sorry, it's not just going to rip apart instantly and separate and leave a void behind. What it does is all the rock and soil above that bedrock is still in place. And as the bedrock's trying to pull apart, that rock and soil is getting thinner and kind of stretching out. So as it's getting thinner and stretching out, now that magma underneath it has enough pressure behind it to be able to punch through those cracks and openings. As it punches through the cracks and openings, we end up with those underwater mountain ranges that form. So we get a rift valley first. That was this part here, where the thinning of the plate, much thicker here, much thinner here, and it kind of forms like a valley shape to it. Inside that valley, we're going to end up getting mountain ranges that form. And those underwater mountain ranges can be very, very, very high. So when we look at these divergent boundaries, we have our oldest plate near the shoreline of these oceanic plates, because the oceanic plates are going to be where this divergence happens. We don't have a lot of continental divergence. Most of it's oceanic divergence. So as that's happening, our age of our crust, the age of the underwater surface, it's going to be the newest where the mountain range is at, where the two plates are pulling apart from one another. Right at the boundary is where the newest crust is at. And then it's going to get older as we go towards the shoreline. And then in the Rift Valley, we end up with those underwater mountain ranges that form. So that's what's happening at divergence. Hopefully you guys understand that. When we look at in text form, because again, they're going to ask you to describe and explain. They're very unlikely to ask you identify questions. I did get that clarification from College Board. It's going to be mainly going to be explain or describe this process type of questions that you're going to see. So if it would ask you to describe what's happening at the divergent boundary and explain what that means in terms of geology, you'd have to say first that plates are pulling apart from one another. That would be your description part. Your explain part then would be that the plates become thinner at the boundary. Upwelling of magma is going to break through the thin surface. That's going to create underwater volcanoes, new crust. And I'm not going to put island arcs here because that's not true with this. So it's just going to create volcanoes and new crust. It's also going to have the potential to cause earthquakes. And a great example of this is that mid-Atlantic ridge. So again, forget about island arcs. Don't think about those yet. We'll talk about those here in a second. So that's going to be divergent. Again, this would be the explain part where you're supporting your description with material. So our next boundary type is going to be convergent boundaries. So what I want you guys to do, look at this picture to the right, and I want you guys to first describe the processes that are going to occur at a convergent boundary, and then explain how that would result in certain geologic features. So if you haven't paused your video yet, pause it and answer that question. All right, coming back. Hopefully you describe your processes as a subduction zone is going to occur. And that's a key vocabulary part. You need to note that with convergence, it's the two plates trying to come into one contact with one another. But what we have when we have an oceanic and a continental convergence occurring, the more dense plate slides underneath the less dense plate. So we're going to have the more dense plate. Think about a head-on collision, Prius and a pickup truck. Pickup truck's much more dense. So it's going to slide under the Prius, and the Prius is going to get flung up in the air. So when we see this happening, that the convergent boundary creates a subduction zone. So we're going to describe creates subduction. And then you'd want to go and describe what subduction is. Subduction is when one plate slides underneath another plate. Now, how that's going to result in certain geologic features, it's going to create a few different things. It's going to create mountain ranges, or it's going to create an island arc if it's oceanic convergence. So if it's continental oceanic convergence, where the two plates are coming in contact and we have a landmass here and an oceanic plate here, when that pushes under, that's going to create volcanic mountain ranges. That's what's happening off the coast of Chile with the Andes Mountains. They're volcanic mountain ranges. When we look at oceanic, this is like what's happening near the Philippines, Japan, places like that. As the plate subducts underneath, it's going to melt into the magma. So as that plate slides down in, the rock from that oceanic plate melts into the asthenosphere and the mantle, creating more magma. That increased magma pressure pushes to the surface and creates volcanoes. If the volcanoes are on land, it's going to create a mountain range. If those volcanoes are out in the ocean, that's what's going to create island arcs. So that would be what you'd want to say for the explain part. So looking at our last type, this is the transform boundary. The main thing that we want to note here is that we have a high likelihood of earthquakes. We don't really see mountain ranges or volcanoes happen, but we do have earthquakes happen a lot. We have earthquakes that occur at divergent boundaries, at convergent boundaries, and at transform boundaries, but at transform, it's only going to be earthquakes that occur. And that's because you have the two plates trying to slide past one another. But as we talked earlier, there's a huge amount of friction, jagged, rough edges. So it's like pushing your hands together. That frictional force is there. It's not letting my hands slide, but I'm still trying to pull my hands in parallel opposite directions. All of a sudden, I have enough force that it overcomes that friction, and all of that energy is released in a short period of time, and an earthquake occurs. So that's what's happening with transform. We don't really see any any volcanoes. We don't see any mountain ranges form. It's just going to be earthquake activity. Now, when we look back here at the convergent boundary, we have a high likelihood of it's oceanic. This is where those earthquakes happen that create the tsunamis, because what happens is as that plate subducting under, sometimes that friction builds up and flips that plate that's on top up a little bit. When it flips that plate that's up a little bit, that displaces water, an earthquake occurs, and that water gets pushed inland, creating that tsunami. So what I want you guys to do here, take a second, again, pause the video. As you guys pause the video, what I want you guys to do is look at these plate boundary types. The blue, like turquoise lining, the blue turquoise lines are going to be our divergent boundaries. Again, separating out from one another. The bluer kind of triangled lines, those are going to be our convergent boundaries. And the transform, the ones that are slipping past one another, are in purple. So what I want you guys to do is explain why this area here has so many islands on it using what you know about tectonic plates. So go ahead, pause the video, make that explanation, and we'll come back together. Sorry, I'm eating my plate tectonic Laffy Taffy as we're doing this. So when you look at this area here, first thing you want to note, it's convergent boundary. So the two plates are coming in contact with one another. As that convergent boundary happens, one of the plates is sliding underneath, melting into the mantle. As it melts into the mantle, that's going to increase the magma pressure. That magma pressure has the ability to punch up through the surface and create volcanoes. So what we have here, all through this area, we see massive amounts of island arcs that occur. From the Aleutian Islands off the coast of Alaska to the Philippines over here, to Japan, we see a large amount of island chains that form. And they form those island chains because, again, that magma pressure builds up, allowing the eruptions to occur. Take a second again, pause the video a second time, see if you can remember why Hawaii formed the way it formed. All right, hopefully you guys remembered, Hawaii doesn't have a plate boundary. What Hawaii is through hotspot activity. It's going to be a thinner part of the crust, and where the crust might be, a thickness that's like this everywhere else, for some reason there's a thin spot with, a really, really hot part of the mantle below it. Remember how the mantle's in that convection. Warm magma's rising, colder magma sinking down. So for some reason, right over here, we have a very, very hot spot of magma. The magma just tends to be warmer in that area. So as it's warmer, it's melting down that thinner crust, and the islands of Hawaii are forming. As that plate shifts and moves, it's depositing the islands as it goes. So hotspot islands are different than island arcs. Island arcs tend to happen near plate boundaries. That's what's occurring over here in the Ring of Fire. The islands that are not at a plate boundary usually form as a result of hotspot activity. So Hawaii did not form due to a plate boundary, it formed due to hotspot activity. So hopefully that made a little bit of sense to you. I'm going to ask one more question on here. I want you guys to explain what's likely to be the geologic feature that's occurring here where I have this circle. So go ahead, take a second, pause the video, and explain, not only describe here, let me rephrase this. Describe the geologic feature that's likely to be found in the ocean at that point. Then explain how it was formed. All right, hopefully you described it as being an underwater mountain range that's formed in the Atlantic Ocean. The explanation of why it formed, that underwater mountain range formed as the divergent plate boundary was having those plates slide apart from one another. As they slid apart, the crust became thinner, allowing magma to come up to the surface. As the magma came up to the surface, it erupted and cooled and created an underwater mountain range. Since this is out in the Atlantic Ocean, it's really, really deep water, those mountains didn't have the ability to poke through the surface and create islands. Instead, it created our underwater mountain range called the Mid-Atlantic Ridge. So that's what's occurring here. All right, hopefully sorry guys, I don't know if that came through or not. Whenever I unpaused the video, I was explaining stuff and I didn't see whether the clock was not moving anymore. So let me go back through and explain this again. If it was already explained, feel free to fast forward through this part. My question was to describe what geologic feature was found here and explain how it formed. So my description would be that I'm likely to find an underwater mountain ridge here. So I'm going to have that Mid-Atlantic Ridge be here, an underwater mountain range. My explanation on why it formed the way it did or how it formed was those tectonic plates are trying to pull past one another. As they're pulling apart, the crust is getting thinner and thinner and thinner. As that crust gets thinner, now the magma comes up to the surface. As the magma comes to the surface, it erupts, solidifying, creating mountain ranges in that rift valley. So that Mid-Atlantic Ridge formed as a result of the plates pulling apart, becoming thinner, magma erupting through the thinner crust, creating the underwater mountain. That would be enough to get your describe point and your explain point. Now, the thing I want to touch on here, remember how we said we don't usually see too much continental divergence. The one exception to that is going to be this area right here in Iceland. And that's why Iceland has so many volcanoes. Since those two crustal plates are starting to pull apart, the crustal surface is really close to the magma already. Iceland's a very, very good spot for geothermal energy because the crust is very thin there. As the crust is pulling apart, now that magma is able to erupt, and it's erupting at the surface to create volcanoes. Most of the time at convergent boundaries, it's out in the middle of the ocean where the water's way too deep for that magma ever to reach the surface. Right here at Iceland, though, the crust tends to be thinner, it's above water already, so we end up with volcanic activity. So hopefully this makes a little bit better sense as far as describing tectonic plates. So I have a quick test for learning. Ask yourself, can you describe the geologic changes and events that occur at convergent, divergent, and transform plate boundaries? Take a second, you can pause it now, you can see if you can do that. So hopefully you said at divergent boundaries, we're likely to have underwater mountain ranges and rift valleys form. At convergent boundaries, we're likely to have mountain ranges form if it's on land. Two continental plates pushing together are going to shove upwards into the air because since they're both continental, neither one's more dense than the other. So they push upwards, creating those mountain ranges. Those are going to be like the Himalayas and mountain ranges like those. When we have that happening with a continental and oceanic plate, now the more dense plate slides underneath, subducts down, melts into the mantle. As it melts into the mantle, creates more magma pressure, allowing eruptions to occur, and we end up having island arcs and island chains form. That's what's happening at the convergent. At transform, that's where we're likely to have the earthquakes happen as that energy that's stored is released all at once. So hopefully you guys understand plate tectonics, and this first section is done.